Okay, continuing our review for quadratics. Let's look at this one. So what you're actually looking at is last year's test. So some of this material goes back, but don't use this as the exclusive review, I said, because we may have covered material that, wasn't on the test, but was in some of the reviews. So really it's everything from 5.1 on. This is a graph of a quadratic that is in intercept form. So I know that intercept form is y equal a, x minus p, x minus q. And that tells me that the y-intercepts are at p0 and q0. And I know the axis of symmetry is p plus q over 2. So this is all stuff that I know. So the direction of opening, that is going to open up. So it's going to go like this. And the x-intercepts are going to be at 3, 0, and, excuse me, back up. I made a mistake there. Let me write that. Remember, our formula has a minus sign built in, so it's x minus p. So it's x minus negative 3, 0, and 1, 0. Okay. So remember, this formula has that minus sign, x minus p. Sometimes it might help to write this as, then that's x minus negative 3 and x minus 1. So that means my y-intercept is at negative 3, 0, and 1, 0. Axis of symmetry. So if I look at whatever p plus q over 2 is, that is going to be equal to negative 3 plus 1 over 2, which is just negative 2 over 2, which is negative 1. This is a line, x equal negative 1. Axis of symmetry, that's the equation of a line. X-intercept, those are points. They have xy coordinates, okay? So x-intercept at negative 3, 0, right here, and 1, 0. Axis of symmetry is at x equal negative 1. That's a vertical line. So I have that. I need the vertex. The vertex is going to lie on the axis of symmetry. So x equal negative 1 is the x-coordinate of the vertex. So let's plug that into our original equation. 2 times negative 1 plus 3, negative 1 minus 1. So that's going to be 2 times 2 times negative 2, which is just negative 8. So the vertex is negative 1, negative 8. Negative 1, negative 8 is right here. So I've got the vertex, I've got the x-intercepts, I know that it opens up, so this parabola does this. The domain, negative infinity to infinity. The range is negative 8 to infinity. So that's it, just using vertex form and graphing that parabola. Here we have something based on a parabola in standard form, but it is an inequality. First thing I would do when I look at this inequality, that's a greater than. So I do not want to miss the fact that this will have a dotted line. It will have a dotted line. It will open upward. Okay. So standard form is ax squared plus bx plus c. And the axis of symmetry is x equal negative b over 2a. And the y-intercept is the point 0, c. So if I look at this, the axis of symmetry in my case is going to be x equal negative of negative 8. So that's a negative b over 2 times 2. So that's going to be 8 over 4, which is 2. So x equal 2 is the axis of symmetry. So I draw a dotted line at x equal 2. The vertex. So the vertex is going to be the coordinate at x value of 2. So I just need to plug that into my equation. So we'll say at 2, I'm going to have 2 times 2 squared minus 8 times 2 plus 3. So that's going to be 8 minus 16 plus 3. So that's negative 8 plus 3, which is negative 5. So the vertex is going to be 2, negative 5. The vertex is a point. So at 2, negative 5, I'm going to graph that point right here. So that is my vertex. The y-intercept, I can just look at the value of c. That's the point 0, 3. So 0, 3 is here, and that means I also have a point which is right here. So now I can draw. Now keep in mind, I said dotted line. So I'm going to draw this with a dotted line. So forth. And now I just need to figure out where do I shade, okay? So in this case, I mean, there's a shortcut. If I've always solved for y, that greater than means I'm shading above. So I know it's going to be this area above that vertex, but I can always just test to make sure. So I can test, I'm going to test the point 0, 0. Pick a point that is not on that graph. So let's plug this in. So I'm trying to test y greater than 2x squared minus 8x plus 3. My test value is going to be 0, 0. So is 0 greater than or equal to 0 minus 0 plus 3? Is 0 greater than or equal to 3? The answer is no. 0 is not greater than 3. So that means 0, 0 is not part of my solution. So if that's not part of my solution, then my solution has to be this area right here. Okay. And again, if your equation is y greater than or y less than, y greater than means you're going to be solving, you're going to be shading above. Y less than means you're going to be shading below. Okay. But it's always good to test a point just to make sure with that. That's the end of page 2. We'll come back for page 3.